Hello guys, today is Friday, so we are going to look at data compression, we are going to look at data storage as well. These are the two topics for today. So before we go into the video of the day, please subscribe to my YouTube channel. Also, please follow my socials on the comment below. The aim for this channel, my main aim on this channel is to give you at least 3 videos a week so that you keep entertained as well as being educated. So let's get into the business of the day. Thank you very much. Alright guys, so today we want to talk about data measurement, which is our first port of call, and then later on discuss about data storage. So any video that you can find on either WhatsApp, it can be YouTube, or wherever that you can find a video, it is measured in some units. So today we want to discuss about the scientific terms which we use to refer to these units of data. So the smallest one is referred to as a bit. That's the smallest measurement unit of measurement of data. And then from a bit we move on to a nibu. A nibu has got 4 bits, and then we have got a byte, right? A byte has got 8 bits, and then from a byte now you have a kibibyte. So a kibibyte has got 1024 bytes, and then from a kibibyte we've got a megabyte. A megabyte has got 1024 kibibytes. So from a megabyte we move on to a gigabyte. 1 gigabyte has got 1024 megabytes. So from gigabytes we move on to terabytes. So 1 terabyte has got 1024 gigabytes. From terabytes we now have petabytes. So petabytes consists of 1024 terabytes, and then the last one is an exabyte. An exabyte has got 1024 petabytes. So this is how data is measured. So for workings and so forth, anything that you can want to know about data storage and the relevant workings which we must apply when you come across any question, you can comment below on the comment section below. Comment below, and then we can make some arrangements. My numbers again, they are in the comments below. All right, thank you. So see you in the next video, which is data compression. Alright, so let's move on with the topic of the day. We want to talk about compression. Right, so data is everywhere, right? But usually it exists in enormous, or maybe we can say huge quantities. Alright, so it will be difficult for us to keep on piling data alright, on our devices. Sometimes we'll end up running short of some memory space and so forth. So it has to be compressed somehow. Let's say this video that you are watching right now, all right, the process that I've gone through for you to be able to see this video, I first recorded it, and then I do some edits, and then I do compression and so forth. All right, and I just posted it the way it was when I recorded it, then it will be very large. So when data, or maybe when a video is just posted without being compressed, there are so many things involved there. We'll talk about the advantages and disadvantages of compression later. So the first part, of course, is the definition of the word compression. So it is a method that reduces the size of a file by using an algorithm. So that is compression. It is a method that reduces the size of a file by using an algorithm. So there are two main types of compression that we have. We have got lossless compression, we have got lossy compression, right? So those are the two main types of compression, lossy and lossless. So with the lossy compression, we are simply referring to a method of reducing data without loss compression. It's a method of reducing the size of a file by altering some elements within of that file that are not necessary, or that will not affect the overall quality of the file, be it a sound file, be it a picture, right? So we can use lossy compression by altering some elements within the picture that will not affect the overall view, the overall quality of the picture. And if it is a sound, again, we alter some repeating patterns, or maybe those sounds that cannot be perceived by our human ears. So this is lossy compression. And then the other one is lossless compression. So with lossless compression, now there are some files which we would want to reduce, but we would not want to lose anything. We would not want to lose any element of that file. For example, if it is a text file, yes, we can compress text files, but we cannot afford to lose any. We cannot afford to lose anything, because if we lose any element in a text file, then it means, our text or maybe our message will no longer have the meaning. It will no longer carry the meaning that it should be. So there are some files that we should compress but without losing anything. For example, it's a text. All right, so using lossless compression to reduce a text file, what we simply have to do, let's say we have got a text which says, look outside, it's snowing, right? It's snowing, look outside. Look outside, it's snowing. It's snowing, look outside. So as if you got that, if you get it correctly, look outside, it's snowing, look outside. There are some words which are repeating there. So what you simply have to do, we have to create a table which we refer to as a lookup table, so that we index all the repeating words, right? So with that, we will be able to compress the size of that text file but without losing anything. So that is how we use lossless compression in reducing the file of a text file. And the other one, let's say we want to compress a picture, but we don't want to lose any bit of it. So what you simply have to do, we use an algorithm which is referred to as a run length encoding, right? Run length encoding algorithm. So as you all know, all the colors that we have, a picture is just a combination of colors. So all the colors that we have, they emanate from the RGB color scale, right? Red, green, and blue. So if you've got maybe pink, right, it's just, it depends on the amount of red that you have put in your in making of that color, the amount of green, the amount of red, right, RGB. So let's say we have got our picture, which is, let's say, is just the dimensions is just 5 by 5, and then maybe the first 2 units, or maybe the first 3 cells, they are painted in red. The following 2 cells, they're painted in white. Another maybe 3 cells that are painted in yellow. 5 cells that are painted in green, and so forth. So instead of writing Y for 5 yellows, or maybe R for 5 reds, what you simply have to do, we simply have to count the number of reds that is arranged consecutively. Let's say, for example, we have got 5 reds running consecutively. We simply write 5R, right? So we have reduced from 5 bits into 2 bits, right? If we have got maybe 3 yellows that are running consecutively, instead of having 3 bits, we can reduce to 2 bits, right? You can reduce to 2 bits by just writing 3 R depending on the color. So this is how we use the run length encoding in reducing the size of a picture without losing any element. So basically, this is how data compression is done. Thank you very much. Please subscribe, follow my other social media platforms on the comment below. My aim is to produce about at least 3 videos a week. So I'll try to do that on Wednesday, Thursdays, and Fridays. So I'll do that consecutively on those 3 days. So please subscribe, share, and like. Thank you very much.